Hi everyone, welcome to KQL Café. It's June 2026, and I'm here together with Alex and with our guest Saar and Diana. And today we'll have some fun about KQL, IRQL, and lots of good stuff. First, to begin, I've prepared some news as always. That's us, KQL Café, and then agenda. So first things first, KustoCon. We're set to have KustoCon end of October 31st in Zurich in the Microsoft office. There we have a lot of nice speakers, good sponsors, and we'll have some KQL fun.
Yeah, and let me add, I got some feedback like, what are those sessions about? So we've been chasing, we trust our speakers, they always deliver good content, but stay tuned. In the next couple of days, you will see a little bit more about, the exact session details. Yeah.
Cool. And news. So basically we have some highlights. If you go into the Defender portal, there are all these new cool tables, the agentic AI stuff, AgentsInfo. There's a lot of new things coming up in AI land, also local AI, so the Olama stuff. It's getting places, so it's good to play a bit with those kind of data to see what you can detect. I think Alex already wrote some agentic queries on your blog, or?
Yeah, I'll talk about them at the end of the session a little bit. Yeah.
Cool. And next. We've been digging and we saw a really cool detection by Ian Hanley. He wrote a small detection for cloud logging suppression where you can disable the logging, the Azure activity logging. And he made a pretty good detection around that. So be sure to check out his blog. I think it's also a new blog. He has a nice new logo, a lot of cool stuff happening there.
Yeah, and also, this is just one example of a query that he mentions in his blog, but I really recommend looking at this because this is like a first stage where, if the attacker gets that far, first thing he does, we know it from, the local client, impair defenses, right? According to the MITRE attack technique, locally on client. So typically, people try to disable, Defender, McAfee, semantic, and whatsoever. But this is more on the cloud side where, one of the first attempts to basically impair defenses or to disable logging is happening in the cloud by, disabling, in this case, the Azure activity logs and much more. So definitely give this blog from Ian a read. It's it's nicely written, well explained, and a lot of valuable KQL in there as well. Yeah.
Cool. Next up. So our good friend Silvio from Italy, he made a nice portal about KQL queries, rules, repositories. It's a bit like the KQL search, but this has some new layers, some additional features. You can play a bit more with it. It's a fun playground to work with. Also, if you want to contribute to the project, you should reach out to Silvio because he also wants to work together with people to expand this portal into a more fun place. Next one. So this one is also cool stuff. There's the TIFCE, which is the TI feed content evaluation. Sergio Albeia also once spoke about it, and it's to qualify your threat intel feeds. I can also show that one around a bit. So basically, if we do switch window.
Yeah, and this is really a cool story to me because this is something that Sergio started, I think, about 2-3 years ago. And Mikhailos basically, continue to develop on top of that, this workbook, but also this whole idea, this methodology around the TIFCE, line of thinking. Yeah.
So basically, if you go to the GitHub, you can download, or you have the deploy package. From there, you have to enter in your resource ID, which is the long resource ID of your log analytics workspace where your Sentinel lives in.
Now, don't make the mistake that I made. So last night, Gianni and I are always geeking around on Monday evening before this session. And, my workbook wouldn't work because I'm used to enter the workspace ID. Little friendly nudge to Mikhailos, he decided to accept the workspace resource ID, and that's a big difference. So if you deploy this workbook, go to the properties of your workspace, and there you find the resource ID instead of the workspace ID. Yeah.
Basically, if you deploy it, you have some information about your TI feeds, the source of your threat intelligence. Where does it come from? Is it original? Is the quality good? Where does it live? There are some nice metrics in here to give a value to your TI feeds, if it's good, if it's not good. So be sure to play around with it. As you can see, the Defender TI feed now in the last day, we have 13,000 items. The OSINT digital site was an old feed, which was there, but no longer active. That's why you see my demo tenant long old feed. I should clean it up once. I think Alex even shared a script once how you could best clean up these kind of old feeds. So this is a nice thing. If you work with TI, be sure to download the workbook.
Yeah, and as always, because we are in KQL Café, if you wonder how to, what's behind this workbook, simply go into edit mode, drill down into the workbook, and look at the KQL queries behind those data grids.
And then the next one, where we found another source, Ridgeline Cyber, and on their blog they had some nice threat hunting queries for basically, some of these are like the default things you start with, like new IP addresses, OAuth, consent grants, those kind of fundamental things which you want to monitor from your Sentinel, from your Defender. You can find some queries here. As always, if you get a new query, play around with it, see if it matches your data, try maybe to replicate the activity you want to monitor with it. And then it's a quite nice source. Then the most important thing of the day, let's go through our guests. We have Diana and Saar who will be joining us. They will have I think they can introduce themselves better than I can. So I guess the floor is yours, guys.
Introduction first.
Yes. Hi, everyone. My name is Diana. I'm a security research AI engineer at Microsoft. This is my colleague, Saar.
Hi, I'm Saar. Both of us are working for the CISO CDO office here at Microsoft. I'm an architect here. And both of us are working a lot around KQL.
Yeah, we love KQL. We live, eat, breathe, sleep. I was joking with Gianni earlier. I have dreams of KQL. Like I wake up and I'm like I'm in a panic thinking about joins. So it's super cool we're super grateful to have been invited to speak on this forum. This sort of community is super valuable to us, interacting and sharing ideas with practitioners who live and their day jobs are doing what we do, and is super valuable to us. So thank you so much for having us, Gianni and Alex. We'll go ahead and get started. So we'll be presenting on IRQL and lithograph, and Saar can go ahead and start on IRQL.
So basically, like a year and a half ago, we started looking at what you're looking right now, which is in KQL in many cases, the queries become extremely long, extremely intricate. let's say, a wall of text at the end. Yeah, and the reason is not necessarily something that needs to happen. You see in many cases like a pattern that is repeating a lot in the same query, perhaps different parameters. And you might see some make sense to change the names or trajectory names across the board because the different data sources come with different naming convention. Hey, is VAP a very important person or virtual IP? Nobody knows. You need to guess. And a lot of data sources that might change under the hood because somebody decided to. And at the end, you get to a join that a single line of join that needs everything. And this is why you've created a lot of text to make that happen. And the question that has risen is, first of all, is that actually necessary? The immense copy paste that you do every single time? And also considering you've mentioned AI earlier in the earlier here, so basically AI, this is hard for AI. And auto KQL is not really easy because the intent is the hard thing. Why did the one that actually written this query written that? So that is something that we wanted to see whether we can actually solve or at least make easier. So here comes IRQL, or Incident Response Query Language, which is basically a set of query functions that encapsulate the logic and the hidden arcane knowledge that people gathered through the years into abstractions with basically expressing queries in the terms of the semantic meaning, the intent. The name of the function is something which makes it easier for both human and AI to understand why are you doing what you're doing, and hiding the logic, the complex logic sometimes comes underneath. And one might ask, hey, but functions have been there in Kusto for a while. What's new? So you'll see a bit later on that we've organized them in a set of families of functions. And also the naming convention has, like in code, if you're writing in C# or Java or JavaScript or whatever, the name of the function has an intent and has a meaning that makes everything easier. So I've mentioned the families of functions. The main, a bit more than that, but the main 4 families of functions that we've created for IRQL are, as you can see here, the first one is get, which is a set of functions that is intended to hide the source of the data and wrap it in a nice way. If somebody changes the source, they've moved this ingestion source to something else. You've moved from one EDR to another EDR. Something happened that changed the data, and the names have changed, but the data itself is more or less the same. So this hides the source. It down projects the amount of columns that you have because, hey, you might have a table with 600 columns, but you actually need like 20 of those, and 99% of the time. So why have this huge table that you need to down project anytime? You're gonna down project anyhow. It renames the columns to something that actually makes sense. Again, I've mentioned the VAP. Give it an actual name. Is it a virtual IP? Is it a very important person? Something that makes sense. And in many cases, we've also seen, hey, application written with a capital A, lowercase a, app. All the names are different. Joining after that, just a second, how should I join with that on something else? That's not easy. So those functions are creating a consistent schema. The filter functions are building on top of those and down filtering the data that you have. In many cases, you have like a repeatable logic, a set of either word clauses or something else that you need to do again and again. I have this information. This information includes information about emails, but they're not directly in a specific columns. I need to build them either from a JSON or whatever, but I need to down filter the set of the information that I have with the right word clauses to get information. So this is where the filter functions are coming in and down filtering the data to what we actually need. Extract, this is hiding the arcane knowledge that people gathered over the years. They're doing a lot of extents, parsing JSONs, creating new columns from all kinds of ways, breaking the URL to domains and hosts and so on. you have it. It's hiding that, and it has a name now that makes sense. Extract domain from URL, something like this. And then people actually, or AI actually know what you mean and how to do it. And this hides this. And in many cases, those functions hide a lot of logic inside them. The enrich functions, they have two main types. They're hiding mainly joins and lookups. They have two major types. The ones is like how to join on something, which column is more important to join on. I have 40 columns in the table that I'm joining on. What is more relevant? People not necessarily know or remember, and that makes that easier because the function gets as a parameter the column they actually need to join on. And the other thing, sometimes the join is complex. One great example that we've seen is joining with IPv4 information. That tends to be pretty easy. Joining with IPv6, its ranges, not necessarily straightforward. Can we hide the join? Is everybody knowledgeable on how to make this join? Not necessarily yes. And so this is encapsulating the logic of the join and makes things way easier for people to actually do this. So one of the things that we basically got from that is, remember the wall of text, like from a couple of slides ago? After IRQL, you're going to see something which is way, 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 way shorter in many cases. Way shorter to document. The names are basically showing the intent here, like extract sign-ins user agent category. So extract from sign-ins information the user agent in the category. Pretty simple. The underline under the hood might be extremely intricate, lots of code, nobody understands what's going on. This is like way easier, and now it's a single line of invoke, and everybody knows the meaning.
Yep, and so what SAR just introduced is really at its core a concept, creating KQL queries as a set of these composable functions can be applied to various and implemented in various different domains. And so we've released these some IRQL functions in various different contexts. So one of them is with the KC7 data set. If you're unfamiliar with KC7, what it essentially is a hands-on cybersecurity learning experience that essentially is a bunch of different modules of incidents in which you're pretending to be an analyst in a particular company, and you're trying to solve an incident. You're trying to find threat actors, maybe you're threat hunting, or you're doing incident response, and you're writing KQL queries over the synthetic data set that the team has created to hunt and find threat actors. And so it's a free learning game that anyone can play and learn more about cybersecurity and hunting and threat hunting and investigating incidents through real kind of hands-on learning experiences. The KC7 group, the organization that runs this, they're a nonprofit that creates these synthetic data sets, and you have your whole KQL interface where you can run queries and find your threat actors and learn. And this has really been handy for us and as well as a lot of the security community in terms of releasing examples of queries and tooling on data sets that are open source. You know, in security, a lot of our data sets are super proprietary, super sensitive. You know, it's internal sign-in logs and internal like Azure access and things of that nature. But we really just huge shout out to this organization, this group. They do a lot to help folks learn about KQL and cybersecurity, and they also offer folks who want to share ideas, these open source data sets that are that are very vast to showcase ideas like IRQL. So huge shout out to the KC7 group. We've released a set of KC7 IRQL functions on a couple of the modules that can enable folks on these data sets to do gets, to do enriches, and to do extractions. These are on the actual KC7 clusters, and we've released some onto Twitter and to LinkedIn and GitHub. And so essentially you're able to solve a couple of the KC7 modules completely with IRQL functions. So instead of having kind of these walls of text of parsing and doing all this stuff, you can also approach solving KC7 with these composable functions in which you can learn what the functions do, but then you can reuse the functions. The functions become these reusable kind of modular components of logic that can become repetitive. And also the schema is aligned too. So you can learn how to solve something like KC7 with aligned schemas where you can call these enriches and these sorts of joins. And so this is one of our most kind of complete open source implementations of KC7 that Saar, me, and John have worked towards releasing. We also have a couple other contexts in which we've released implementations of IRQL. There's a set of open source data sets that you need an API key for. If you only pass a few requests a day, they're free, but you might need to pay extra later. But let's say like you are in you have access to the Defender XDR datasets, but you want to bring in some other datasets that you have, like virus total or something of that nature. You can actually call the virus total API and enrich and collect data from virus total and pass it through their API and call it through a KQL query. And so what we've done is we've released some IRQL functions on GitHub that essentially do this API call within KQL, given an API key, and then down project the data like Saar was describing. We do down projections and rename as well, like down projections actually rename the columns to the IRQL standard naming convention. So that way, if you want to, for example, look at file event creation or file like file events, you can just invoke virus total data on your file hashes. And so joining and getting file hash enrichments is just one line of a KQL versus, like doing the API call yourself in KQL and passing in the API key and doing all this different stuff and like reprojecting the names and doing the join. Like this just becomes one reusable Kusto query that you could call versus doing this kind of figuring that yourself and then copying and pasting the same logic every time you do it and sending like the same wall of text to the next person every time you do it. Alex, you have a question? Sorry, you muted if you're saying anything.
Yeah. So first comment. So I learned something new. I can do a evaluate HTTP request. Okay, that's super cool. I didn't know that.
Yeah, you can do it specifically in the Kusto Explorer web application. So if you query Kusto often in on the desktop application, if you query Kusto KQL often in like the web portals, and I don't know if you can do this, but in Kusto Explorer, the desktop application specifically, if you write this call out policy here, this web API call out policy, you can do evaluate HTTP requests, and then you can do HTTP requests or API requests to various different endpoints that you're interested in, and that's a really great way of pulling external data sets that are like HTTP requestable, which opens the door to a lot of things. And so that's one of the benefits of IRQL is like you can, when you want to access these sorts of data, you can make these functions that get this data for you. So you don't have to do all of the manual evaluate yourself every time. And then it also, like Saar described, it does the renaming for you to the IRQL standard naming, because all these external data sets, these open source data sets will have very different schemas to what we might have in the Defender XDR or Sentinel data sets. So it's a really great way of just aligning the schemas off the bat and kind of codifying that logic to get that data in the first place.
Yeah. No, that just catch my eye. So definitely gonna try that. And if that would also be possible natively in the, let's say advanced hunting, that would be awesome. And my other question is, for those that might not know this, I mean, Microsoft is opening the threat intelligence API, at least for those customers that are E5. I believe last summer they announced this, and this is going to be rolled out in the next couple of months. So yeah, that was my second thought as I've been playing with that in a private preview. because the Microsoft tracking kill is also behind an API. Yeah. Okay, but this is really awesome. Okay, evaluate HTTP request. Okay, that's what I'm gonna dream of tonight.
Yeah. Yeah, I can send
Cool.
we published this function in the markdown in a gist, a GitHub on gist, so I can send it over in the chat afterwards. So you can just copy and paste this and try this out on your own. But remember,
Cool.
you have to, big caveat, you have to alter the callout policy on your Kusto Explorer cluster to make sure that it's
figured
okay
out.
to
Yeah.
run this. And then we have the similar, we create a different one of this as well, OAuth Sentry. It's this really rich data set that provides some enrichments on cloud applications. This is also another handy data set you could do the evaluate HTTP requests on as well. So we released a couple of these. We also released one for vulnerability scanning as well. So those are all in our gist, and I can link them in the chat after the session. We've also released, Microsoft released the AUD graph logs a couple months ago. When that was released, we kind of hopped on the opportunity and released some IRQL functions for these as well, so some getters and some enrichers. And so you can start to kind of look at the AUD graph logs from the lens of composable IRQL functions. And we were looking at some of the queries that folks in the community were writing, and there were some parsing that could be easily codified in a function. So we codified some of those in functions and we released those, and I can link the gists after I'm done presenting as well to some of these. So that's a little bit about IRQL. What IRQL really does is it helps people kind of like Saar described, people and AI as well, understand intention and create simpler queries in the tabular, or what we call relational world. We're also really interested in enabling.
Before graph, another tiny note is important. One of the cool things about the naming convention of the IRQL is the autocomplete. If you're working with autocomplete, you're starting with, I want to enrich something, and it would immediately offer you the options on the different tables. I want to enrich IP with, and then you'll see, okay, for a second, I can enrich IP with a domain. I can enrich IP with something else. That becomes way easier and way more intuitive on how to do the work. Back there.
Yeah, that's a really great point. So the autocomplete really helps you Alex.
Yeah, sorry, I have one more question because on one hand, I thought, okay, it's super cool if you can provide an API key. Can you also do that with the H sign so that the string actually gets obfuscated, so it's not ending up in logs in plain text?
That's a good question.
Yeah, we'll probably need to look into this.
We'll probably need to look into that. I don't know. Let's follow up offline afterwards. Yeah. We'll chat more. Yeah. That's a good question.
Good. Thank you.
I don't think we've tried that yet. Okay. So yeah, we were discussing IRQL primarily in the tabular, or we call relational world thus far. So enabling folks to query tabular or relational data. Our team has also been really interested in exploring how we can enable folks to create knowledge graphs, like nodes and edges, out of some of the tabular data that we all live and breathe in every day. And so we are going to discuss IRQL for graph for a bit. But while it started off first is, there's tons of different types of knowledge graphs in security. In the last 10 to 15 years, there's been stuff like Bloodhound, Azure Hound. There's really great products like EKG and etc. That are really posture or attack graphs. There's also threat intelligence graphs. People use abstract syntax trees for security, for reverse engineering. There's process trees. There's tons of different types of knowledge graph applications in security. This presentation will primarily be about this 6th bullet here, activity graphs, which are essentially knowledge graphs, nodes and edges that are hydrated with your activity log data. So, a lot of the data that's represented in tabular form right now, but hydrated into a knowledge graph. And this is, we're really interested in this because activity logs are really how we see threat actors. Like the only way you know if you're compromised is through the logs. The only way you find threat actors is through your logs. And so enabling the folks to graph this sort of data is very interesting to us. And so even from a row of data, or every single table has a graph just waiting to be born, right? There's entities, and even in one log of data, there's entities like IP addresses and user agents and usernames, and there's inherently relationships between these entities. You know, like IP addresses initiate authentication to a user that has a password, some password hash, and so there's inherent relationships between these entities within one log of data. And this is just one way of modeling, right, a single row of data. Source IP maybe initiates authentication to a user that has a password hash, a particular password. But there's also multiple different ways of modeling just one log of data. For example, for a different analyst might look at this log of data and be really interested in the host they're authenticating it to, or they might be interested in the user agent that's going on, that's being used for this auth request. And so there's multiple ways of modeling one row of data or a table of data as a knowledge graph that is really dependent from person to person, or even investigation to investigation. For example, sometimes when I look at sign-in logs, I'm really interested in the application ID, versus sometimes I'm really interested in the user agent. And sometimes I want to model some things as nodes, versus other times I want to model them as properties on a node, or sometimes I want to model them as edges, and I want to see different shapes and different graphs that represent different structures of my data. And so I guess there's no one really usual correct way of modeling data. And so in turning tabular data into knowledge graphs, there's a couple different routes to take. One of them is taking tabular data and processing it, ETLing it, cooking it into then a graph database. So taking this tabular data and processing it, cooking it, and putting it in a graph database, and then querying that graph database. This can be something like a Neo4j or a Tinkerpop, etc. What we're really interested in is, and what this presentation is really about, is kind of spinning up ephemeral knowledge graphs off of tabular data that don't necessarily require this kind of ETL or batch processing or cooking of data. Immediately kind of spinning up small ephemeral, a few hundred to a few thousand nodes and edges size knowledge graph that really represents your workspace and the data that you're considering during a singular investigation or a threat hunt. And so I'll introduce Kusto Explorer real quick and then hand it over to Saar. A lot of this presentation and what we're going to discuss relies on the free desktop application, Kusto Explorer. It's essentially a different application to query Kusto data. So you might be familiar with querying KQL in the Azure or security portals. This is a different application to do so. It's a desktop application. And what's really handy is that there's natively a graph UI experience. Like you can create graphs, you can visualize them natively in this desktop application and query them and do lots of sorts of cool things that Saar and I will show in a second. And if you're wondering, well, then how do I access my Sentinel data in Kusto Explorer? There's actually this handy endpoint you can create here, this cluster endpoint here. So you take, like you guys were describing earlier, the resource ID of your login analytics workspace and the workspace name. You just fill in those variables. And so instead of querying your data here, you can query them in this free desktop application and repro some of the things that we're going to show. I'll pass it off to Saar.
So main graphs. Kusto Explorer had, for our work, several commands that allowed you to create a graph from your table. Basically, if you've transformed your table into something which is graph-like, Then you can call makegraph on top of this, and makegraph will transform it again to a different format and visualize that is in the UI interface that Diana just showed. The main issue with that is the transformation. Transformation from a regular relational table to a graph table is far from easy. You need to write, as you can see, this is a basic example here, quite a lot of code, KQL code to make that happen. A lot of code to create the nodes, a lot of code to create the edges, then everything that defines them, from the node size to the color to the icon to everything else that you want, the relation type, everything else that you want to define. It's quite a lot of code and a lot of text that you need to add. So here comes the thing that we also released recently, which is IRQL for graph. To the family of functions that we already have, we've added two major functions that will describe several more families or wrappers to their functions. The first and the most major one is the function we call lift to graph. Now, basically, this function, instead of you've just seen, it's pretty intricate to create a graph table that you can call makegraph on top of it. Lift to graph hides this. It gets a nice little JSON that we're gonna see in the next slide. And code is hard, but JSON is pretty easy. It's a very specific format on what is included where and how. And you're creating your JSON. And then you just drop the JSON as a parameter to the function. And immediately the function transforms your table according to the JSON to a graph table. And then you can call makegraph on top of this. Now, makegraph is, again, something that has its parameters and so on. And now the parameters would be very, very specific to the ones that are being created by lift to graph. So we've released another function called graph random view, which is working on top of this specific result of lift to graph, and allows you to get the design here of the graph and the template for it, and basically it transforms the graph table that has been created by lift to graph into a visualized form, as you can see on the right side of the slide here. So talking about JSON, the JSON, as I've mentioned, is pretty simple. And this is the only thing you actually need to create instead of KQL code. You define the set of node types and the edges, and the node types have some parameters, basic parameters like type and ID. Most of the cases are the same. The key column, which is the base of the node, the properties of the node, like Diana's mentioned earlier. In many cases, you want to have a node called IP, and the IP will have perhaps a domain as a property and a private IP, perhaps, and some other stuff that you want on top of the same node. So there will appear as properties, some default values, the icon that you want to add on top of this that will be presented on the graph to make it nicer to present or just easier to understand. Same with the edges. You define the what is connected to what pretty easily, a source and a target, the type of it. So what is the connection between, what is the type of the edge? This belongs to that. This is translated to that. Then again, you might have properties for the edge. Everything that Kusto Explorer UI is supported also in JSON. Not all the fields are mandatory. Only a small set of them are mandatory. So pretty straightforward. Okay, so we have the IRQL, and now we have the lift to graph, and we have the graph random view. Can we add more? Can we build on top of the IRQL functions that we already have, wrap them in a nice little way, perhaps automatically create other types of functions to make it a graph relation of those functions? And the answer is yes. We created several new families of functions called enrich node, enrich graph, and extract node, which are basically wrappers on top of the IRQL function. The enrich node is a function that traps the enrich function, enrich functions, and the result is adding more properties. It does not have even parameters, just wraps the underlying regular enrich function and transforms the result of lift to graph table into something that has each node has more properties. It joins the graph that you have with more information, which is relational, and the result is still a graph. This family function is more intended for one-to-one enrichments. Otherwise, you might get into strange situation where you have different types of data inside the node. But when there's like a one-to-one conversion, let's say an IP to domain, it's pretty easy to do this inside the enrich node. Enrich graph is a bit more flexible, but needs a bit more work on the user side of that function. And now you can join anything you like as more nodes and more edges. Again, relational table, new relational table that is joined on the current graph table, and the result is still a graph. But now you have the input parameters, yet another JSON, same format of JSON like in lift to graph, that models the new information. You do not need to model everything, just the things that you've added. And by the way, side note, one can imagine a library of JSONs that can be stored somewhere, shared between people. This is how I'm mapping this kind of table that Microsoft publishes, something like this for XDR. And you can even wrap those in functions and make them accessible. Get or filter table mapping, something like this, one can imagine. Extract node, same graph wrappers for the extract functions, the RQL functions. Again, extracting information from current nodes and adding more information as properties of the existing nodes. Those three types of functions, the enrich node, enrich graph, and extract node, they have a very basic template that you can auto-generate for all the enrich and extract functions that you already have. It's just a nice little wrapper, and you can auto-generate all of them pretty easily. Graph full type property, this is a specific function. It's not a family of functions. In some cases, you need to merge several different nodes of either the same type or the same property into one Uber node to represent an information, and Diana will show in a couple of slides an example around this. And this function allows you to merge the different nodes into a single node pretty easily, make this happen. And graph render view, we've already covered.
Yeah, so this is a super short demo of showcasing what Saar just described. This is the KC7 Kusto cluster, one of the game that I discussed earlier. You can actually hook up to their open source Kusto data. So that's what we did here in Kusto Explorer. And we're going to graph some of the data with the IRQL functions. And so what this is I think this is just taking I think 500 auth events from the KC7 Azure Press game. And just pacing back real quick, this is really just like 3 lines of 3 Kusto functions. Or this is auth events, it's 2 Kusto functions. Auth events, we do lift to graph, and we pass them the mapping JSON. This is the mapping JSON. Here, I'm just showing the mapping JSON just so you guys can see it. But we actually have this exact same mapping JSON saved off as a Kusto function. And so you can actually call the JSONs as Kusto functions. You have to copy and paste and rewrite them all the time. And so really, if this was a Kusto function, this would be 3 lines of KQL, just auth events, lift to graph, and graph render view. And then suddenly, we'll see we have a graph just rendered of the auth events, auth requests. And so suddenly there's a graph. You don't have to ETL or cook or change up your data a bunch to have a graph that's visible for you to interact with the query. It's just right there for us with just 3 lines of KQL. Because usually making knowledge graphs out of this sort of data can be more challenging. Saar showed an example earlier of a make graph. You have to write a whole wall of text where you have to manually omit nodes and edges, or write Python or code to this is a pretty simple way to just have a graph accessible for you, an ephemeral graph, like a snapshot graph accessible to you. And so off the bat, just visually, there's even some shape and structure to a lot of data that's kind of hidden in logs. For example, a lot of the benign behavior for this scenario is all these little small clusters on the sides that you can zoom into and take a look at. And this kind of circle in the center is where some of the anomalous activity is, and where you can zoom in further and start to investigate. And you can see the various node types and hover over them and look at their values and their properties, and figure out what nodes you want to continue to investigate and enrich or filter, et cetera, enrich or fold, or et cetera. And so this is a different example. This is some of their mail events. It's just like I take 400 of some of their mail logs. And again, it's just showing off a different ontology or a different graph model and a different data set. And so here we call lift to graph and graph render view on this JSON mapping. And then just like that, we get a graph of mail events of who's sending what to who. This graph doesn't have as much clear shape or structure as the previous one, but this is just going to show that you can do this on multiple graphs. And the same way you can union tables in Kusto, you can also union graphs in Kusto, because for IRQL graph, graphs are just tables of nodes and edges. And so this is a graph, these are two graphs that we have that I stored off. An email graph during a certain period of time and a sign-in graph during a certain period of time, and then we that are lifted. We union these two and we run graph render view. And then we get to see here that we get to see the union data of email events and sign-in events of who's signing in to what accounts and receiving or sending certain emails. And so we can union these two tables and kind of see within a very short period of time what's happening in your environment. And yeah, so this is that graph. You can start to investigate and see around these sort of things. In the KC7 data set, the email messages themselves have a column called verdict. So you can imagine something like MDO or some email scanner in your environment will label emails as whether or not they look benign or suspicious or malicious. If there is some like phishing, if it looks like spear phishing or phishing, or if there's some I don't know, some like weird zip files in the emails. And so what we're doing here is we union those same graphs I showed previously, but then we call that operator fold that Saar just introduced a few slides back. Just a reminder that operator fold, what it does is it takes nodes that of a certain type, and if they have a same property value, they collapse them into one big Uber node. You can think of this to be similar to group by in Kusto if you've ever tried that before. So here we're folding all of the email message nodes by the verdict property. And so we'll see in a second, all of the email message nodes that have the verdict property value, like benign, will fold together into one Uber node versus all the ones that are suspicious will fold into a different Uber node, et cetera, et cetera. So you can start to look at like at a high level, like what sort of patterns and things are going on in your environment. And so in this case, that big blue dot there is, I think, all of the benign email messages that are folded together. In a second, the recording here, we'll zoom into it. There we go. And so another handy thing about Kusto Explorer is, well, one, you can set icons to be your nodes. So here we set the icons to be all these different nodes here. And two, you can set your node size to be by a particular column value. So here we set the node size to be by how many nodes are folded to make this Uber node. So the nodes that were folded, the Uber nodes that had a lot of nodes collapse into them become bigger, just as a visual cue. And so here we can see that what fold does is it creates this Uber node. It rewires the edges to keep the same kind of rough graph structure. So all the edges should be the same and now just are rewired to connect to the Uber node. And we actually save off the node IDs as properties to the Uber node. So you can see which nodes are folded in to create the Uber node and how many were folded as well. And so this is the benign, I think this is the clean email verdict folded. There's also, I believe, this dot right here is the suspicious verdict, and there's another one for malicious somewhere in this graph as well. And so then you can kind of start to investigate and see the patterns of your data at a higher level this way. And the other handy thing about the Kusto Explorer kind of graph experience here is that graphs are also, data structures outside of just like images that you can interact with and scroll around. And so here there's even a graph, a query pane here where you can run GQL-like queries and actually run queries over this graph that you just lifted with only a couple lines of KQL. And so here I believe I'm looking for signs associated with emails that were received by that are connected to some of these folded nodes. Then I could have filtered it to say like, oh, where I believe this is where workbook actually is blocked. So you pass around here and see which emails were blocked and who's signing into what from that, like who's 2 hops away from receiving an email that was blocked and stuff like that. And so you can quickly kind of filter and down select what you're looking in your graph if you just see a hairball of nodes and edges. So that's a little bit about lift to graph. We have a ton of more examples that we posted on X and LinkedIn as well, and we'll link the actual markdown files, the gist, that we published on GitHub after I'm done presenting, so folks can play around with it themselves if they're interested. We've released a few set of functions, but we're actually releasing more because there's a lot more that we've created that we're slowly starting to release to folks. We have deduping 2 graphs. So sometimes when you union 2 graphs together, you might have nodes that are the same. And so what Kusto Explorer does right now, it will pick just one of the nodes randomly based off of the ID. And so sometimes you might lose properties. Like let's say 2 nodes have the same ID, but one has more properties than the other. When the graph is actually created by KQL, when you call make graph, it'll pick one of the 2 randomly. We're going to release a function that does merge dedupe, which just dedupes and backs up all the properties into one node. And so I can talk about the next 2.
Yeah, so the other 2, I'd say one is a function, one is a family of functions. The filter function is now that you have a graph, you can do a word clause on top of this graph, but it's not necessarily easy because you need to remember the structure of the graph and so on and so on. So we're going to release a filter function that allows you to define a very basic predicate set to say this is how I want to filter the graph. Now it's more intended to support the next thing that I'm going to present, which is the pivot functions. The idea behind the pivot functions is in most investigations, you're actually doing a pivoting. You start from a large data set, and then you're saying, this set of IPs is interesting. I want to explore those. I don't explore everything. And the enrich functions that we presented till now added information to everything that you have, and everything's being presented, which can become cumbersome, fills your UI with a lot of nodes and not necessarily needed. So the pivoting functions are doing an enrichment, for example, but on top of a specific set. It's like a merger of a filter function and a dedupe function. Basically, what it does is you define a predicate that you want to enrich on. For example, I'm interested in the IPs that start with 106 dot something, and enrich only those. And what you'll see is the function maintains the original graph because you want to understand where you started from. You do not want to actually down-filter those. You want to say, this is we call it the investigation, basically. This is the query that brought me here, and then down-filter to whatever is needed, and add in just the branch, the enrichment of just the things that you actually need. So you see the basis plus the enrichment for the specific things that you wanted, and you can continue on and on. What will happen, you'll have the basic graph where you started from, and then you'll start to branch out as a tree inside the graph of the things you're actually interested at. Okay, tiny little bonus topic for like a couple of minutes for the ones who are actually using Kusto Explorer, or perhaps you want to ask for those kinds of capabilities in different implementations and different products. During the work on top of KQL, and we've done a lot of this work, as Dan has mentioned, on Kusto Explorer, the desktop app, we've seen that some things might be missing or might make your life easier, quality of life features that will make everything easier. So one thing that we've went on is contributed to the Kusto Explorer code and added some nicer set of quality of life features. The first one that I'll mention is copy as array. Kusto Explorer had for a long time the copy as data table. You can mark cells in the results table and transform it into a data table. But in some cases, you want to say, well, something in something else, and that something else is easier to just write an array. So you can copy a set of cells and right click on it, say copy as array, get as array, paste it wherever you need, and here you go, you have an array for it. Copy column names was there basically forever, but now there's like a keyboard code, Control-Shift-N that allows you to do it in a simpler way. If you're using, I'm guessing, Windows and or browsers and applications, so on, one thing that some people are using is you want to scroll left and right if the page is bigger than the screen. So one thing that we've added is using Shift plus mouse scroll up for left or down for right. So you can scroll around. If you have a huge query or huge set of results and you just want to not go with the mouse and stretch the scroll bar here or there, you can just do this and scroll right or scroll left, which is pretty nice. And there was an option for quite a lot of time to show only the selected values. But in some cases, you want to mark some selected values, say, oh, for example, those are benign. They're not interested to the investigation. Can I hide those? So you can unfilter, but you can just hide with Control of left click. You can hide the selected values that you just marked on the results table. Some cool things that are upcoming. One thing that is very effective for working with IRQL is we found out that you have, in many cases, you have your query, and then you said, okay, just a second, I want to add something more. So there's several options. One option is add the new line and run everything from scratch. It might take a lot of time with a huge data set. The other way is you have the result table, which you can access with $result and work on top of this. But then your code becomes dotted with $result, $result, $result. It tends to be pretty cumbersome. So we've added support, which is, again, upcoming, not being released yet, but expect it soon in Kusto Explorer, to use Alt-Shift-Enter. You mark the new part of the query, click Alt-Shift-Enter, and then you get the code that is being selected running on top of the result set of whatever you just had a second ago, which makes things like almost like pipeline of KQL queries. You can do an investigation. Oh, just a second, I need to add something more. Write it down, mark it, Alt-Shift-Enter, and run it. The second thing is we've seen that IRQL for graph might be very effective for presenting code as results as graph. Now, the main issue that we had with the graph UI as it is now is that it's pretty static. Once you transform, let's say with lifter graph, you transform the graph into something that is visualized. You can filter it, you can do graph match on top of it, but you cannot add more information, you cannot do an enrich. If you want to do that, you need to close the UI, run the functions again, and start the UI from scratch. So we're adding capabilities to make the graph interactive in such a way that you can call more code that is maintaining the underlying table format, but not the data. So you can, for example, if you have enrich node, enrich graph, extract node functions, or something around this, or filter nodes, something that is maintaining the graph columns, the graph schema, you can work on top of this graph and see changing in an interactive way inside the UI, makes the investigation way easier. And you'll have the ability to basically run KQL snippets that maintain the schema on top of the visible graph. Multi-select for nodes in the graph UI, you were able only to select a single node. Now you can set a selection for several nodes and work on top of them, and also under support. So you've done some queries, but hey, just a second, the last query was too fine or too not find enough, and you want to take back a bit and change it. So you can press undo and start over from that section, not starting from scratch. So those are some cool things that are upcoming.
Yeah, I am especially excited for the results one that Saar was describing. I often run queries that are very long and take a while to finish. And then I'm like, oh, shoot, I really wanted to add that extra where clause or do that extra thing, but I want to rerun the whole query again and wait another like however many minutes. And so I use that result, like bracket result thing, and then add a line of KQL to it. And so half of my KQL files end up just being result something, result something, result something. So that keyboard shortcut, I'm really excited. Sorry, I implemented that. And I'm like, that's so cool. And I'm really excited as a practitioner to have that. I feel like it's just a small change, but that keyboard shortcut will be really handy, at least for my workflows. But these are all super, super cool. So yeah, that's all we had for you all today. Thank you so much for having it. We can open it up to quite any questions or discussions or whatnot.
Cool stuff. So I liked the session. For me, I have a small question because we have the IRQL, but there's also ASIM, and I'm not seeing the two linked yet. Are there plans to make sure that ASIM is also integrated, or?
So IRQL is basically a concept. Can we integrate it with other stuff? Of course. The answer is, in general, is yes. Will we? That's a good question. We need to see whether if the community would like us to have something like this, we can consider something like this. Again, the IRQL concept is extremely, extremely flexible. We had different data sources, different types of information wrapped around this, and different concepts. It's not the only family of functions that exists in Microsoft. Other groups are having their own sets. This is a concept that we've developed for our line of work and our needs. In many cases, we're working with other groups. We've seen that other groups are saying perhaps this, perhaps that, and when it's needed, we're just adding more and more capabilities under the hood for the IRQL set of functions. And again, even more families of functions. As you've seen, we started with 4 families. Now there's the graph families of function that, things evolved.
And there might be more.
Yeah, and we're gonna make more, and we're gonna make more families and more capabilities as we see fit, or as the community again asks us to make this happen.
Another small question.
Yeah.
So basically, you guys use it day-to-day basis. Which of these features amazed you the most? Which is the most handy or most useful or most fun to play with?
That's a new question.
Yeah, a lot of my job, especially right now, is investigating threat hunting right now, and the enrichment functions and the getters, I feel like, are super, super useful, and the filters and the extractors. Okay, a lot of them are, because there's a lot of the queries that I run, there are a lot of repetitive enrichments. So for example, no matter what the data set is, there's usually IP addresses, or there's usually something that I might want to enrich IP addresses, or there's just common sets of enrichments that I need to do on common sets of entities. And so the getters are really useful because no matter what the data set is, it immediately has the renaming to the correct schema, like the IRQL schema that I expect. And so I don't have to copy and paste query logic. For example, there are a bunch of different timestamp namings across a lot of different data sets. Like one data set might call it environment time and camel casing, another in Pascal casing. We've standardized it to just env time and Pascal casing. And so all of my time filters, I can just copy and paste regardless of what the activity data set is. Or like a lot of my user agent filters or whatever my filters, I can just copy and paste them or call IRQL functions that encompass those filters as where clauses, that encompass those where clauses as functions, because the naming convention is the same. So I really, just having this expected right naming convention is so simple, but it makes me spend less brain calories, less brain power thinking about just project renaming or what's the right column here, how do I rename this, or what's the right whatever join key, and focus more on what is the best query that I can write for this? Like, how do I make the screen more efficient? How do I find the threat actor? Like, it makes me focus and spend more brain power on the actual cybersecurity and what I'm looking for versus how do I project rename, or how do I make this, how do I get rid of columns, et cetera, et cetera. Like, it just does it for me. And then the enrichments are really handy too, because joins, they're not that complicated to write, but sometimes it just takes extra brain power to write them, and all I have to do is write them a couple times, or rely on other enrichments that people have written, and I get to have those off the bat, and just call enrichment functions versus discovering where to join things, or what's the right what's the right data source to do this, or how do I do the right web request, like express whatever web request to something with the right API key when I could just call a function that does it for me.
Mentioning about the also the graph functions, one of the things that we've seen in the past, the analysts are, you might see, divided somewhat between the ones who like tables and the ones who like graphs. In many cases, it depends on where they've grown as an analyst, in which company. Some companies are more focusing on graphs, some companies are more focusing on tables. And the nice thing about graph is Kusto is a very, very powerful tool around threat intel analysis, and everybody's using it. But hey, I'm used to graphs and not to tables, and it's hard to understand what's going on inside the tables. So now you can visualize everything you want in the way that you're used to, which makes things simpler for those specific types of analysts. The other thing that we might mention about graphs, when you want to present your work, presenting your work as a table, it's pretty hard. Nobody understands what's going on inside the table if they're not going into the details and how it's structured, and they're not familiar with this. Showing something as a graph is way easier to explain, way easier to show and present. So that's like an added bonus for that.
Yeah,
that is also something that
totally. Yeah, and there's some, in addition to presentation, there's some like operatives that we've created that for our KQL graph that you can only really do with the graph data structure that you can't necessarily do in the tabular world, or there's not as clear of an equivalent. Like, one of the powers of graph outside of visual is also just the data structure itself. Like, your data is fundamentally it's a new data structure. And so thus you're open, you have way more interesting operators to ask only graph questions to that are harder in the tabular relational world. For example, in the tabular relational world, you're kind of limited to the operators that you have. You have where clauses, you have joins, and you have summarizations. But in graph, you can do things like folds. Like, you can see, okay, you can do something like fold. Like, isn't really as much of there's group by, but it's not.
Graph matches.
In graph matches, you can run graph queries, you can run like graph queries alone, in addition to folds, enrich graph, things of that nature, or even like pivots, or or just seeing the shape of your data. Like, I remember the first graph I showed, there was immediately structure to it. There's immediately like, oh, benign data is on the edges, it's those small subgraphs. But if you see like one IP address making a bunch of auth requests to a bunch of different hosts or a bunch of different users, that could be immediately like a simple password spray or something like that. Like, there's a lot of inherent shape to tabular data it's a lot more challenging, or you might have to run 5 different KQL summarization queries to understand that shape, versus if you look at the graph, you can immediately see the structure and the shape of it, and that might be hidden in logs, or it might take a few more queries to understand from the logs.
Yeah, one thing worth mentioning is John Lambert, that is still leading this initiative. He has a very famous quote around attackers think in graphs, defenders think in lists, and among this case, attackers will win. Now, this is breaking the barrier. This is, okay, how do I transform the tabular data into graphs to allow me to think in graphs when it's needed?
Cool.
So our mission here is to make KQL and everything that's in the family approachable to everyone. And I also sometimes experience myself when I speak to some real nerds, I'm like, do you have a data science background? Yeah, blah, 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 Python. And then I sometimes really feel stupid, like, oh no, I don't get this, because behind all these data sciences. So if I want to get started, and by the way, I now and then talk to the, Kusto product team. I said, guys, please make some approachable examples, not those, strange like C minus N and, something I can relate to, like, 1,000 fishes in the water or the signing logs and whatsoever. So to if I want to get started to engage, and this is more for the audience that will watch the recording later, or for those still online. I know, Diana, you have your IRQL stuff on your GitHub list. Is that still the place to go, or is there meanwhile maybe a more central repository where also Saar is contributing, or is your gist still the way to go?
The gists are still the way to go. There's out-of-box example queries in there for games like KC7. That's the main place we're publishing stuff. There's a bunch of other examples that we post on X that are copy and paste. Like you can take the exact text that I tweeted and just put it in Kusto Explorer and run it and get a graph. But I think the main place I would start is the KC7 IRQL functions, because it goes hand in hand with the KC7 game. So you can learn more about security, and the datasets are open source. So that's where I would start.
And that means that in KC7, I find everything that you also published on X, or do I have to start crawling all your X tweets for the nice?
No, I think all the functions you need to solve it, though JoJo's hospital and volley times and Azure Crest, or mainly JoJo's hospital and volley times, are on the gist. They have all of the functions that you need to solve it are on there. Not necessarily all the solutions are there, but that's a great idea. Maybe we could publish a blog post where we go through the whole KC7 game and give all the answers to the KC7 game in IRQL functions. That's a great idea. I could do that. Just to see the full end-to-end walkthrough, because we have a couple examples, but I don't think the full incident, all the solutions to the incident are on there.
Yeah. Okay. Cool. Yeah. I mean, I will just say it as I told many people who have been posting on X and LinkedIn, and I also tell you, please just make a GitHub repo. People will appreciate it. That will be super awesome. But yeah, I think Gianni and I we're definitely gonna spend some Monday evening time on this, and yeah, I really find it an approachable thing, especially to me. I don't know if that's the right thing, but everybody is talking about skills nowadays, right? With AI, and I was thinking like, this is like a KQL skill, right? Like, I mean, instead of bothering about project away, and I don't want to have this and all those join, super cool concept. I really love this, and I rather see it as a toolbox, right, that everyone can kind of customize to their own needs and use cases.
You hit it right on the nose there. I use IRQL functions for some of my skill files. It's a lot easier to, like Saar mentioned earlier, to expose AI to IRQL functions and versus like the raw KQL logic, because like all those lines of parsing columns is not useful for the LLM. Like it's kind of sometimes a waste of tokens. If it's just like if half
now
of the
that
query,
tokens have become so expensive.
now the tokens, they're only going to get more expensive.
And it's not just tokens. Again, in many cases, it's just easier for AI to understand what is needed, what is the tool that's needed, because it has the right name for it.
What's the intent? Like what are the semantic, like a lot of queries get super long, so they look really complex, but they're actually semantically, they're only doing one thing. Like it's just a lot of long renaming or extending. And so if we can hide that in, like Saar mentioned, functions that represent the semantic intention, it's easier for AI to use, it's easier for humans to use. Your tokens are spent more wisely. Like it just makes sense to me.
Yeah. No, super cool, super cool. Yeah, we're definitely gonna spread your word on the world about this. Yeah. Cool. Let's see. Any questions? No. I guess it's also maybe too hot. At least we have still 32 degrees here, so.
Yeah, I heard about the heat wave going on in Europe. Oh my lord. You guys have AC where you are?
Sorry?
Do you have air conditioning?
No, not where I am here. Oh. No. Yeah, you guys are based where?
In Redmond, Washington.
Around the Seattle area. Yeah.
Okay. Yeah. I'll be in Canada soon, so let's see how the weather is there.
Where are you based out of, Alex?
Switzerland.
Oh wow, that's lovely.
Middle of Europe. Yeah. Cool. Yes. Thank you so much for coming to our show and talk about all this. We'll definitely add all the stuff to the show notes. And yeah, I mean, as we tell all the guests, if you have anything news to talk about, updates, please share them with us. And we're happy to have you back on the show whenever you like. Yeah. Good.
Thank you so much for having us.
Yeah. Okay. Then let's wrap it up, Gianni.
Cool. So
Thank you so much, Saar, Diana. Great to have you. Feel free to stay, or if you have to go back to work. For us, it's the end of the day. Cool. All right, Gianni. Yeah, let's get into the what have we done this month part. Yeah.
So for now, it's the local agent one for you.
Yeah, so yeah, if you can quickly open this one, then we don't have to do sharing ping pong. So yeah, agents, everybody's talking about agents. And of course, in Defender, we now have a new capability about local agent discovery. So if you, can you quickly share maybe the query, Gianni? Yeah.
I wanted to open it, but my mouse got stuck. So now I'm typing your address. Bear with me for a second.
Okay. Yeah, the intent here is, for those that have access to Defender for Endpoint, I think it now went public preview. It will basically create an inventory. So in Defender, under the assets node, in addition to devices and identities and whatever we have out there, there's now also a section called agents. And there you'll find, agents and local agents. Yeah, a little hint here, because, when I published this, I got overwhelmed by DMs over social, like, this isn't working. And the reason is because Microsoft is in the middle of a transition of renaming your table. So, there used to be the AI AgentsInfo table. And that one is depreciated. Yeah, don't even try it, because the whole schema is so different. It's not just a table name, it's everything inside there. Yeah, and I happen to be a lucky guy who got early access. So, and for those that have early access, you will notice that the AI, the AgentsInfo table, apparently Gianni doesn't have access to that one. So if you have AgentsInfo, as we showed in the beginning of the show notes, it's actually publicly announced that Microsoft will change this table name. And the good thing is that with the new table, we also have way more information about whether people have auto-approved all the actions on the AI, or whether people are using MCP tools. etc. And I can tell you, I've been running that query on a couple of customer tenants that were already transitioned to the new table name. And it's mind-blowing, how many agents people are running locally on MCP servers that they have configured. So that's the query there. Exactly. If you can quickly go back to the GitHub. Yeah. There you see a bunch of queries. No rocket science. Just looking at what agents do we have, or total number of agents per device, or the last query is basically showing you the MCP servers. Yeah. Good. Let's move on to the next query that I wrote. MDE schedule task. Now I have to give a little bit of context, why I wrote this. So if you can go back to the GitHub, please. Yeah. So the intent here is basically I'm working with a colleague supporting a client to move to a SIS security baseline across all their servers. And that's not just about applying some new GPOs or Intune policies. That's goes beyond that. At least that's how our company works. We look at everything that's running on those boxes, including any accounts running as scheduled tasks, because if you don't put them into your new policies in the allow run as batch job or allow to run locally, those scheduled tasks will fail. At the same line of thought, we also wanted to actually understand and discuss with the customer, do you actually know what scheduled tasks are running in your environment and in which user context? So basically what these type queries here do is more like a, creating an inventory of, for example, all scheduled tasks that do not run in the system context or in the network service context. That already gave us a lot of, service account names that we could correlate. We were also able to identify, scheduled tasks still running in VB script code. That's something you want to look at because at some point VB script will be depreciated. And so on. We found batch files, PowerShell scripts with credentials that were, lingering in folders, that aren't secured, etc. So yeah, if you wonder, in your environment, what scheduled tasks are being executed, take a look and modify the queries as per your needs. Yeah, that's all for me for this month. Yeah.
Cool. And then a small one for me. So basically, a lot of people got this email stating, hey, we're gonna retire the HTTP ingest API. And then it doesn't say where people are using it. So basically, this email was a bit hard to track because people didn't know, what are we still ingesting? Because you get the email, you're ingesting something over the API, but it's not stating what. So basically what I did is I took this and I made a small query around it. So basically, let me show my screen again. So basically, this is all related to custom tables. So what I do is basically I search for all tables that ends with CL. And in this case, I'm looking for the last 3 days. You can also do 30 days or whatever your retention is. Then basically I will pack it and make sure that I can figure out basically per table what the columns are and if they would end with S, D, B, G, or T. So basically strings, decimals, booleans, GUIDs, and these are for time. So basically, what I did is I wrote this query, and this way I can quickly figure out, hey, which tables do I have, with the last finishing type. So basically, with this query, you can run it, and you can see, hey, I have Dropbox, I have Okta, I have some other custom table ending with underscore, and then the data type. And then you know, okay, so we need to take a look into this data type and convert it to the new codeless connector framework so that it's no longer ingested over the API, but through all the new goodness. And then you have the DCRs and all the good stuff to ingest data. So this saves me quite some work this month. That was the last slide for today. As always, Alex and I would like to thank our guests and our viewers for being with us. It's a lot of fun again, a lot of things to think about, new things to learn IRQL. I saw some of the expos already, but now I have to spend some more time with it. So good stuff.
Yeah, thank you so much for joining. So just in case you're going to miss us in July, August, we're having a little break. And maybe we'll share a video of something that Gianni and I recorded earlier this year while we were in Redmond. And if not, we'll be back in September. And yeah, once more, KustoCon is coming. It's coming after you. No, seriously. KustoCon, end of October. Go to the website. Either join online, and more preferably, if you can, join us on site in Zurich, Switzerland. And yeah, in the morning we're gonna have a workshop, and in the afternoon we are going to have sessions with people like Olaf, Matthias Borg, Bert-Jan Pauls, Fabian Bader is going to be there.
Sergio?
Yeah, Sergio Abea, Stefan Schorling from Sweden as well. Yeah, yeah, and we're working on another guest as we speak. So yeah, stay tuned. We'll share some more details about the agenda of KustoCon soon. Okay, I wish everybody a nice evening, and yeah, see you back in September. Thanks for being with us.
Thank you all.
Bye-bye.